Question 1. Len 1 over 6 equals. Here we can see that it's a direct question in which we can use calculator to find the value of this expression direct. But pay attention, when you are writing this expression, we have to write it in this form. Len open bracket 1 over 6. Don't write it as len 1 divided by 6. This is wrong. You will not get the correct answer. You have to write it len and between brackets put 1 over 6 and you will get this value, negative 1.79. Question 2. 3e to the power 3 len x to the power of 2. Here we want to find this expression in the simplest form, or we have to find the simplest form of this expression. We have two methods to solve this question. The first method is by using properties of this function, the properties of the function e, or logarithmic functions. Here we have e to the power 3 multiplied len x to the power of 2. As we said before, that we have constant multiplied by len. This constant will be a power to the expression, so it will be e to the power len x to the power of 2 all to the power of 3. From properties of exponents, power inside, power outside will be multiplied by each other. E to the power of len x to the power of 6. We have a property here in exponential functions that e to the power of len of an expression equal the same expression. E to the power of len of an expression, the answer will be the same expression. So the answer direct will be x to the power of 6. Here we use the properties of exponential and logarithmic functions and rules of indices to simplify this expression to write it in the standard or in the simplest form. The other method is by using a hack. What's this hack? As we said in a previous question, we choose any value for x. Here we have to choose a positive value for x and substitute in the question and in each choice. As example, we choose x equal 3. If you put 3 in the place of x in the question, it will be e to the power 3 multiply, and you have to put multiply between the number and len on the calculator, of len 3 to the power of 2. The answer will be, if you use calculator, 729. We will put the same value in each choice, and the choice which will give the same value is the correct answer. If you put 3 in the first choice, like this, you will get 1.325. This is not the answer, because it's not equal 729. In the second choice, len x to the power of 6, so it will be 3 to the power of 6 equal, on the calculator it will be 1.758. It will be wrong because it's not equal to 729. If we put 3 in the third choice, it will be 3 to the power of 5 equal to 143. It's not the same answer. The last one, 3 power of 6 equal 729. It's the same value as if we put the value in the question. So this choice is the correct answer, as we got from simplifying. Question 3. d by dx cotan 1 over 3x. Here we want to differentiate trigonometric function. We said before that differentiation of trigonometric function is differentiation of this trigonometric function multiplied by differentiation of the angle. Differentiation of cotan is negative cosec square for this angle. Multiply differentiation of this angle equal 1 over 3. By modifying the form, it will be negative 1 over 3 multiplied by cosec square 1 over 3x. This is choice, and this is the answer. Question 4. If f of x equal 2e to the power of 3x, then f dash of x equal what? Here we want to find the first derivative for this function. This function is e with power. Its differentiation is the same function multiply differentiation of the power. So if f of x equal 2 multiply e to the power 3x, then f dash of x equal this 2 multiply will be written the same. We will differentiate this part. We write the same function multiply differentiation of the power. By modifying the form, multiply 2 by 3 equal 6e to the power of 3x. This is choice. Question 5. d by dx 1 over x to the power of 3 minus 1 all to the power of 2. Here we want to differentiate this expression, which is in the form of dividing. As we got an expression in the form of dividing and we want to differentiate, first we will think about quotient rule. But first we have to ask a question. Can we change the form of this expression so we will not use the quotient rule, we'll use another method which is more simple? Sometimes we can change, other times no. If we can't change, we'll use or we have to use quotient rule. Otherwise, we'll change the form of the expression and we'll use another method. Here, this expression, we can change its form. Here it's 1 over x to the power of 3 minus 1 all to the power of 2, so we can write it in this form. d by dx of x to the power of 3 minus 1 all to the power of negative 2. Here it's 1 over, we'll write it up with the inverse sign of the power. So here we have a bracket with power, its differentiation simply 2 parts multiply differentiation of the bracket multiply differentiation of what inside the bracket. Differentiation of the bracket means multiply by the power, subtract 1 from the power. Multiply differentiation of what inside the bracket, it will be 3x power 2. Modify this form, it will be negative 6x to the power of 2 multiply x to the power of 3 minus 1 all to the power negative 3. Here we don't have this form in our choices, so we have to simplify this expression to get the same form. Simplifying here by writing the bracket with negative power and denominator with positive power. So here we got an expression in this form, and we already have one choice with the same form, which is this choice. And this is the final answer. Question 6. If f of x equals sine 2x, then f double dash x equal what? Here we have an expression, or this function, which is trigonometric function, and we want to find f double dash, which is the second derivative of this function. Here we have to pay attention what he gives and what he asks. Here he asks to find the second derivative. If he gives the first derivative or the function, what we have to do? If he gives the function, we have to differentiate 2 times. If he gives the first derivative, we'll differentiate only 1 time. So we have to pay attention what he gives and what he asks. Here he gives the function, so we'll differentiate this expression 2 times. The first time, which is f dash of x, trigonometric function, as we said before, 2 parts. Differentiation of the function multiply differentiation of the angle. Differentiation of sine is cosine 2x. Multiply differentiation of the angle equal 2. So it will be 2 cosine 2x. To find f double dash of x, we'll differentiate this function another time. Equal to, differentiate this part, cosine 2x, 2 parts multiplied by each other. Differentiation of cosine equal negative sine of the angle. Multiply differentiation of this angle. By modifying it will be negative 4 sine 2x. And this is the answer. Negative 4 sine 2x. Question 7. If x to the power of 2 plus y to the power of 2 equal 3, then dy by dx equal what? Here we want to find the first derivative of this function, and it's, as we can see, is an implicit function. Implicit function, we have to differentiate each part separate according to its type. It's polynomial, it's trigonometric, it's e power, it's len, whatever it's for. Differentiate each part separate according to its form. And in the part in which we differentiate the letter y, we have to add dy by dx. Let's see. The first part is x to the power of 2. Applying the rule here, multiply by the power, subtract 1 from the power, it's 2x. Here we differentiated letter x, so we'll not add any parts. Second part is y power 2. Differentiate according to its rule, it's multiply by the power, subtract 1 from the power. But here we differentiated letter y, or we apply the rule of differentiation on letter y, so we have to add the part dy by dx equal. Differentiation of 3, there is no letter, equal 0. Second step, we have to make dy by dx separate. So it's 2y dy by dx equal, and move 2x to the other side, it will be negative 2x. We'll erase this part. It will be negative 2x. So by dividing by 2y, divide by 2y equal negative 2x over 2y. Here we don't have the same form, so we have to simplify more. Cancel 2 and 2, it's negative x over y. This is the final answer in the simplest form, and we have already one choice which have the same form, so it's the final answer. Question 8. If the rate of the area of a circular angle plot is increasing by 24 pi square centimeter second power negative 1. When the radius is 2 centimeter, then the rate of increasing radius in square centimeter second power negative 1 is what? Here it's question about rate of a change. Here it's talking about increasing of area, rate of increasing of area of circular plot. So here we have to know what is the rule of area of circle. It's pi r to the power of 2. So dA by dr equal 2 pi r. Here we are differentiating with respect of the variable r. Pi is constant in any place. The rate of a change of area equal d by dt. Its rule is d by dt equal dA by dr multiply dr by dt. The part dr by dt is the rate of change of the radius, which he asked to find. Increasing or decreasing, it's the same, no difference here. dA by dt, he gives its value, which is 24 pi. Put each value in its place. dA by dr, it's 2 pi r. But here we have the value of r, which is 2 centimeter. So in the place of r, we'll put 2. Multiply dr by dt. Simply we'll divide by this part. It's 4 pi. So over 4 pi over 4 pi, 2 pi multiply 2 equal 4 pi. We'll cancel this part with this part, and we'll simplify this side. Pi cancelled with pi. 24 divided by 4 equal 6 square centimeter second to the power -1. So in the question of rate of change, we have to know he's talking about rate of change of which measure, area, volume, perimeter, like this, and write its rule for the given shape, and differentiate with respect of the variable. The variable is radius, is side length, is height, like this, and put the rule. After writing the rule, put each value in its place and find the value of the missed part. Question 9. Which area of those shown in the diagram opposite is expressed as limit of x to 0, summation from x equal 2 to x equal 4, 4 over x dx. Here, this is the graph of y equal 4 over x. Here we have 1, 4 over x, one side negative 4 over x. One side 4 over x, one side negative 4 over x. Here the function is 4 over x, so we are talking about this side, right side. And right side we have two parts of area, but here is talking about from x equal 2 and x equal 4. Here the first area in the side of 4 over x start from 0, ends at 2. So the bounds of this area, x equal 0 and x equal 2. So this is not the area. The second area starts from 2 and ends at 4. So the bounds are x equal 2, x equal 4. So area D is the answer. Question 10. Integration from -1 to 1 x square root of 2x power 2 plus 3 dx equal what? Here we want to find the value of this definite integral for this expression. Here we can see that we have an expression with root. I said before, in any expression we want to differentiate or integrate, we have to get rid of the root by converting it to p power. So we write this root as power. It will be x open bracket 2x power 2 plus 3 all to the power 1 over 2. Square root means power 1 over 2. Here this bracket, can we expand? No. So we'll use integration by recognition. Integration by recognition for a bracket with power. Outside the bracket should be differentiation of what inside the bracket. What is the differentiation of what inside the bracket? It's 4x. So outside the bracket should be 4x. Here we have x, we'll add 4 multiplied. But outside we have to add 4 divided or multiplied by 1 over 4. As we got outside the bracket differentiation of what inside the bracket, we'll apply the rule. This rule is adding 1 to the power of the bracket divided by the new power of the bracket. So we'll add 1 to the power of the bracket divided by the new power of the bracket. Don't write this part again. This part not written another time. What is written only is what inside the rule, what inside the integration. So it's 1 over 4. The integration here will be 2x power 2 plus 3 power 3 over 2 divided by 3 over 2 from -1 to 1. By simplifying these two fractions with each other, it will be 1 over 6 multiplied by, you can write 1 over 6 inside the bracket or outside, it's the same, 2x power 2 plus 3 all to the power of 3 over 2 from -1 to 1. You will substitute one time by 1 and another time by -1, then subtract the two values. The first 1 over 6, here it's 2x power 2 plus 3 all to the power 3 over 2. Here in this case we'll put x equal 1, so it will be 1 power 2. If we calculated, the value will be 1.86. The other one, put negative 1 in the place of x. Power 3 over 2 equal, you'll find it's the same value. If we subtract these two values, it will be 0. So the final answer will be 0. So from this question we have to know that we'll use integration by recognition for the bracket with power if we can't expand this bracket. Question 11. E to the power 5x minus 1 divided by e dx equal what? Here we want to integrate this expression. I said before, we have any expression in the form of dividing. In differentiation or integration, we have to simplify, or to get rid of denominator to simplify the expression, to use sample form or sample rule. Here in this question, especially with e power, pay attention about this question. Any question or any expression, differentiation, integration, solving, pay attention about simplifying the expression with e power using rules of indices. Here we have e power divided by e power. Here it's e power 1. As we stated before, if the power is not written, it's 1. So by using rules of indices, dividing the same basis means subtract powers. So it will be e to the power 5x minus 1 minus 1 dx. So it will be integration of e to the power 5x minus 2 dx. We know that the rule of integration of e power is the same function, but in case it's multiplied by differentiation of the power. What is the differentiation of the power? It's 5. So we have to multiply here by 5 and outside divide by 5. It's integration of recognition for the expression e power. The expression of e power, its integration is the same expression, but in case it's multiplied by the differentiation of the power. So here it will be 1 over 5 e to the power 5x minus 2 plus c. Here remember, this part is not written in the value of the integration. What is written is the part outside the integration, or the value outside the integration. So this is the answer. Question 12. If integration of 2kx of bracket 3 plus x to the power of 2 all to the power of 4 dx equal 3 plus x to the power of 2 all to the power of 5 plus c, then the value of k is. Here in this question, he gives integration for an expression equal another expression. It means if we integrated this expression, we will get this expression. In this direction we will integrate. And at the same time, it means that if we differentiated this expression, you will get this expression. So here we have two-sided question. If we integrated this side, you will get the other side. If we differentiated right hand side, you will get left hand side. It's the same, but which is more simple, integration or differentiation? Here in the expression we want to integrate, we have a missed letter, so it will be difficult. But here this expression is direct and is more simple to differentiate, so we'll use differentiation. If we differentiated this expression, differentiation of bracket with power is differentiate the bracket multiply differentiation of what inside the bracket. So here it's 10x multiplied by 3 plus x to the power of 2 all to the power of 4. As we said in the beginning, this expression is the same the other expression. And here in this question we'll use comparing between two sides. Cancel similar parts here this bracket is the same this bracket, and x is the same x. Still 2k equal 10. So simply we'll divide by 2, then k equal 5. So this is the final answer. Here if you want to integrate, you can by recognition. Here if we want to get this bracket, it will be 2x outside and divide by 2 outside, like this. But it's more simple to differentiate this side to get this side and comparing. So any question like this, using bracket with power, e power and fraction, it's the same idea. Integration of side equal another side, so if we will integrate, you will get the other side. If we differentiate the other side, you will get the same side, as we did now. By comparing the two sides and cancelling similar parts, you will get simple equation in this letter. By solving, you will get the value of this letter. Question 15. The figure below shows the graph of f of x equal 1 plus e to the power of x plus 1. State the range of f of x and the asymptote. As we said before, the range related to values of y, which belongs to real, or the set of real numbers. So domain related to values of x, range related to values of y. Here, values of y start from what in this graph? We can see here that values of y for this graph start from 1, because here it's the minimum value for the graph at y equal 1. But the range will be from 1 and more or from 1 and less. If the graph is drawn up, it's 1 and more, means bigger than 1. Drawn down, it will be 1 and less, smaller than 1. Here it's up, so it will be more than y. It's y bigger than 1. The asymptote. Here, this line is the asymptote, the line in which we start the range of values. But the asymptote here is y equal 1. Here the range starts from 1 or more than 1 and the asymptote at 1. But in the range we used between y and 1 the sample bigger than. In the asymptote we used between y and y the sample equals, because it's equation. Asymptote is a line and we write equation of a line. But here the range is range of values, similar to domain. It's an interval or range of values. So we'll use samples bigger than or less than. Question 13. Find the inverse f inverse of x for f of x equal ln 4x plus 12. This question we have to differentiate between the inverse and the first derivative. As we said before, the first derivative is written as f dash of x, but the inverse is f power negative 1 of x. This is differentiate and this is inverse. Here he asked to find the inverse and he already write the word inverse, but sometimes he will not write it. So we have to differentiate from the sample. First step to find the inverse is to write f of x as y. So it will be y equal ln 4x plus 12. Here, to find the inverse, simply we want to change the subject. In f of x we can see that y is the subject of the expression, or the subject of the equation. To find the inverse, we'll make x the subject of the expression or the equation. Here, first step we have to get rid of ln. To get rid of ln, we'll cancel ln from this side and write e to the power in this side. We can write e power in both sides, but to simplify or to reduce steps, we'll cancel len from here and put e power here. So the expression will be 4x plus 12 equal e to the power of y. Simply it's similar to linear equation. Move plus or minus, then multiply or divide. We'll move plus 12 to the other side. So 4x equal e to the power of y minus 12. Divide by 4, divide by 4, then x equal e to the power of y minus 12 over 4. And here, in left hand side, x will be written as f inverse of x, and we'll write the other side the same, but in the place of y we'll put x. And this is the final answer. Some students change letters from the first step. In this step, they will write x equal len 4y plus 12, and they want to make y the subject. It's the same, and you'll get the same answer. You will get the same answer.
Question 17. If len of x plus 2 plus len x minus 2 equal len 2x power 2 minus 20. Find the value of x. Find the value of x means we want to solve the equation. Here he asked to find the value of x. It's the same as if he said solve this equation. It's the same meaning. Here we have logarithmic equation or equation with len, and we have to simplify to solve to get the value of the letter x. We'll use rules of logarithm to simplify this expression or both sides to get an equation in the letter x, and we have to solve to find the value of this letter. Left hand side, we can see that it's two parts, len of an expression plus len of another expression. As we said before in rules of logarithm, that len plus len equal len of multiply. Len plus len equal len of multiply. So here left hand side we can write it as x plus 2 multiply x minus 2 equal to len 2x power 2 minus 20. Here we have two sides, len of an expression equal len of another expression. One len in left hand side and one len in right hand side. Len of an expression equal len of another expression. It means that the first expression equal the second expression. So here we got quadratic equation in the variable x. By solving it using any method of solving quadratic equations, we can get its value. Simplify brackets and collect like term, make one side equal 0 to get the equation in the standard form and solve. By expanding these two brackets in left hand side, you will get x to the power of 2 minus 4 equal 2x to the power of 2 minus 20. Here by collecting x power 2 in one side and numbers in one side, you will get x power 2 here and negative 20 here. So it will be x to the power of 2 to x power 2 minus x power 2 equal x power 2. Here negative 4 plus 20 equal 16. Here x power 2 plus equals 16. To get the value of x, we have to get square root for both sides. Square root of x power 2 equal x, and we'll take the square root for the other side, which is 16. But here there is an important point. Don't forget in square root to put positive and negative. We got a question before in which we solved an equation which was power 3. We took cubic root for both sides. In cubic root we don't write positive and negative because we have only one value, but here it's square root, we have to write positive and negative because we will get two values. So x equal positive 4 or x equal negative 4. And this is the final answer. But what is the difference between the solution of this equation and the values which are accepted to be values for x in this expression? Here we have logarithmic equation, and we get values of x by solving quadratic equations. Positive 4 and negative 4 are the solutions of the quadratic equation. But which one of them is accepted to be value of x in this equation? This is the question. Not all values for x can be accepted to be values of x in logarithmic equation. If we substitute, you will see that x equal negative 4 is not accepted. Why? Not because it's negative. Because if we put it in the place of x in any part, you will get a negative value. If we put it here, negative 4, it will be negative 4 minus 2 equal negative 6. No len for negative number, so this one refused. So we refuse the value of x, not the negative value of x. No, the value of x, whatever it's positive or negative, but this value makes the value of the expression with len negative. Because sometimes we will get expression like this: x equal len of x minus 5, like this. And we got value x equal 3. Here the value of x is positive, but it's accepted to be put it here? No, because if we put it at 3 minus 5 len negative 2, refused. So here don't refuse the negative value for x direct. You have to substitute by each value of x. The value which makes the expression with len negative is refused. Question 18. If f of x equal e to the power 11x minus 3x to the power of 3 plus 6x to the power of 2 plus 12x minus 21, find f dash of x. Here we want to find the first derivative of this function. In this question you have to pay attention it's first derivative or the second derivative or the inverse. And as we said before, what he gives and what he asks. If he gives the function and he asks to find the first derivative, we'll differentiate one time. If he gives the first derivative and he wants to find second derivative, we'll differentiate one time. If he gives the function and he asks to find second derivative, we will differentiate 2 times. So we have to pay attention in this question. To differentiate this expression, we can see that this expression consists of some parts between all of them plus or minus. No multiplier divided. So simply we will differentiate each part separate. The first part, the second part, third part, fourth part, fifth part, and write answers beside each other. We will differentiate each part according to its type or according to its form. E to the power of 11x exponential, we write the same function multiply differentiation of the power. Second part, negative 3x to the power of 3, here it's direct multiply by the power, subtract 1 from the power. 3 multiply negative 3, it's negative 9. X to the power 3 minus 1 equal 2. Plus 6x to the power 2, it's the same, multiply by the power, subtract 1 from the power. 2 multiply positive 6, it's positive 12. X to the power 2 minus 1 equal 1. Plus 12x, we said before, any term with the variable power 1, just cancel the variable to find its derivative. So here cancel x, it will be plus 12. The last term, negative 21, its differentiation equals 0 because it's constant term or absolute term. Constant or absolute term not means it's a number. No. We can get a term with letters but it's constant, or absolute term, its differentiation equals 0. When the differentiation of the term equals 0, not when it's only number without letters. No. When there is no variable in this term. The variable here in this equation or this expression is x. Any term without x or y here, f of x is equal y. F of x can be written as y. So any term without the variable x or y, its differentiation equal 0. So this is the final answer. We can modify it by writing 11 e power 11x minus 9x to the power of 2 plus 12x plus 12. Question 19. Find the stationary points on the curve negative x to the power of 2 over 2 plus y to the power of 2 over 3 equal 1. Here in this function he asked to find stationary points. If we want to find stationary points for any function, it means we have to find the first derivative and then we have to put the first derivative, which dy by dx equals 0, and solve the equation to find the values of letters x and y. We'll find x, then substitute to find y. Whatever the form of the expression, we'll differentiate according to its form using the rule. Here, as we can see that this expression or this function is an implicit function. So we'll differentiate first to find dy by dx. But first we can write it in this form, negative 1 over 2 x to the power of 2 plus 1 over 3 y to the power of 2 equal 1. Here two parts between them plus or minus, will differentiate each part separate according to its form. Here we will multiply by the power, subtract 1 from the power, so it will be negative x, plus multiply by the power, subtract 1 from the power, it will be 2 over 3 y. Here in this part we will add dy by dx, or you can write it as y dash. So we'll differentiate each part normally according to its form, but in the part in which we will apply the rule of differentiation on letter y, like this, we will add dy by dx. Here we apply the rule on the letter x, so we didn't add anything. Differentiation of 1 equals 0. Second step, we have to make dy by dx subject, or to write dy by dx in one side and all other parts in the other side. So it will be 2 over 3 y dy by dx equal to, move negative x to the other side, it will be x. Here we'll divide by 2 over 3y, divide by 2 over 3y, cancel, then dy by dx equal 3x over 2y. As we get dy by dx or y dash, we have to put it equal 0 and solve. And here we have an important remark. If we have any fraction equal to 0, it means only numerator equals 0. You have an expression in the form of a fraction and its value equals 0. It means only numerator equals 0. So 3x equals 0. From it, x equals 0. This is x coordinate of stationary points. What if we want to find y coordinates, or we have to find y coordinates, but we will substitute by x. In which expression? To find any coordinate, x coordinate or y coordinate, we have to substitute in the original function, not in the first derivative, not in the second derivative. So here, as we put x equal 0, we'll find the values of y. Here y power 2 over 3 equal 1, because this expression equals 0. So y power 2 equal 3. Take square root, and don't forget, as we said before, positive and negative. So here we have 2 points, 0 and root 3, 0 and negative root 3. Here we have two stationary points for this function. Question 20. Find the equation of the normal to the curve y equal 3 to the power 2x at the point 0 and 1. In any question, if you ask to find the equation of tangent or equation of normal, steps are similar. You will find dy by dx and substitute with the point to find the gradient, and use one of the two forms of the general form of the equation of the line, because tangent or normal represented by line. The two forms of equation of a line are y equal mx plus c or y minus y1 equal m multiply x minus x1. So after finding the gradient, you can use any one of them to write or to represent the equation of the line, or the equation of normal or tangent. First, y equal 3 to the power of 2x. We want to find the first derivative, so y dash equal. Here, this is exponential function, but the base is not e. If the base is e, we have two parts for the differentiation, the function multiplied by differentiation of the power. If it's a number, otherwise e, there are three parts. The first part, write the same function. Sorry, it's not e, it's 3. Write the same function. Multiply differentiation of the power. It's 2. And here this part, len of the base. So why here we added this part and we didn't add it if it's e power? Because if we added this part, it will be len e. Len e equal 1, so mentally we cancel it because it will not affect the answer. Here we write it in another form. It will be 2 len 3 between brackets, multiply 3 to the power 2x. After finding the first derivative, you have to put or to substitute with this point or values. It's at this point equal. We'll put x in the place of x and y in the place of y, because sometimes in the expression we have one letter or two letters. So it will be 2 len 3 multiply 3 power 2 multiply 0. So it will be 2 len 3. Usually the value you will get by substituting in the first derivative is the gradient of tangent. Usually it's gradient of tangent. So substituting by the point in the first derivative gives the gradient of tangent. If you want the equation of tangent, you will take the same value in the place of m, in this form or in this form. But if he want equation of normal, as he asked here, the gradient will be upside down change sign. So it will be 1 over 2 len 3 and change the sign to be negative. Here, after getting the gradient, we will use any of these two forms. So I'll use the second one, y minus. This is x1, this is y1. Y minus 1 equal negative 1 over 2 len 3 multiply x minus x1, which is 0. So it will be y minus 1 equal negative 1 over 2 len 3 x. And then if we want to write it in the form y equal mx plus c or ax plus by plus c equal 0, you can do it. If you want to write it as y equal mx plus c, just move negative 1 to the other side. So it will be y equal negative 1 over 2 len 3x plus 1. This is the first form. Or you can collect them in one side and make the other side equal 0. So it will be 1 over 2 len 3x plus y minus 1 equal 0. Here we move this part to the other side and write in order the part of x, then the part of y, then the absolute term. And then here we have two forms for the final answer. You can choose any one of them. Pay attention, here we get the gradient in this form, -1 over 2 ln 3. It's better to leave it in the same form. Don't write as decimal till the final answer. It will be better or more simple to write it or to leave it in the same form. Don't write it as decimal. Question 21. If f of x has a minimum point at a and 0 and f dash of x equal x minus 2 e to the power negative x, find the value of a. Here, as we can see, he is talking about minimum point. To find minimum point or to identify minimum point or maximum point for any function, we have some steps. The first step, find the first derivative and put it equal 0 to find the stationary points, and substitute in the second derivative to know its maximum or minimum, or this stationary point is maximum point or minimum point. In a question like this or any similar question, we have to pay attention what we need or what we ask and what he gives. We said the first step to find minimum or maximum point is to differentiate to find the first derivative. Here in this question, did he give the function and we have to differentiate to find first derivative? No. Here he gives already the first derivative, so we don't have to differentiate this expression another time to find the first derivative. So we will put this first derivative equal 0 direct. This is the second step. We said the first step, find f dash of x and then put it equal 0. He already gives here f dash of x, so turn to the next step, which is putting f dash of x equal 0 and solve. It will be x minus 2 e to the power negative x. Here we have already factorized the expression equal 0, so we can solve x minus 2 equal 0 and e power negative x equal 0. This one is refused because there is no value we can put in the place of x, so the value will be 0. So we have only one choice, x minus 2 equal 0. So x equal 2. Third step, we have to find the second derivative and substitute by this value to know this point is maximum or minimum. Here, this is the first derivative. So to find second derivative, we have to differentiate only another one time. Here, this expression is written in the form of multiplying. So we'll use product rule. First expression or the first part, second part, differentiate its 1, differentiate its negative e power negative x. Cross multiply and between them plus, so f double dash of x equal e to the power negative x minus e to the power negative x multiply x minus 2. Here we have to put the value of x in its place in the second function, in the second derivative. So f double dash of 2 equal e to the power negative 2 minus e to the power negative 2 multiply 2 minus 2. This part equals 0. So f double dash of 2 equal e power negative 2. We can here see that using calculator that this value or the value of this expression e to the power negative 2 will give a value bigger than 0. If the second derivative gives value bigger than 0, so it's minimum point because it's bigger. If it's smaller, it will be maximum. So here, if we put it x equal 2 in this expression, you will get minimum point. So a equal 2. Why a equal 2? Because a is in the place of x, and we said the value of x which makes this point minimum is x equal 2, then a equal 2. and this is the final answer. Question 22. Evaluate integration, the definite integration from e to 2e of 1 over x dx. Here it's a direct question and it's very simple. We'll just integrate this expression and then we will substitute by these values, then subtract by the first value, then substitute by the second value, then subtract to find the final answer. So the first step, we have to integrate the expression. Integration of 1 over x. Here if we have a form of fraction like this, 1 over x, and the numerator is the differentiation of denominator, then the integration will be ln of the denominator, but don't forget to put absolute value sign. So here the integration of 1 over x equal ln absolute value of x. But this part will be converted to bracket like this and put the values here. So we'll substitute by the first value, then substitute by the second value, subtract. So the first one will be ln of 2e. The second will be ln e. Here the first one minus the second one, so it will be ln 2e minus ln e. Here we can remove this sign because this is positive. 2e is positive and e is positive, so we can remove this absolute term sign. As we said before, from properties of logarithm, that ln minus ln equal ln of divide, so it will be ln 2e over e. By simplifying, cancel e with e, it will be ln 2. And if you want to write as decimal, it will be 0.693. If he didn't ask to write as decimal, you can cancel this part. Question 23. Find the area enclosed by the curves y equal x minus 1 all to the power of 2 and y equal root x minus 1. Here he gives the two functions and he gives bounds of integration. If he didn't give the bounds of integration, we have to put y1 equal y2 and solve to find values of x. But here it already gives bounds of integration, which are a and b. Then we'll use the rule direct. It's integration from a to b. It will be from 1 to 2, and the rule is written already in the formula sheet. We can write it first, then substitute. y1 equal, or will be, root x minus 1 minus x minus 1 all to the power of 2 dx. We have to integrate this expression and substitute by these two values, 2 and 1, then subtract to get the value. The value we'll get is the area. Before integrating, as we said before, we have to simplify as we can. Get rid of root, denominator or bracket. Here we have root, so we have to change its form. It will be x minus 1 all to the power 1 over 2 minus x minus 1 all to the power of 2 dx. Here we have two parts, so we'll integrate each part separate. It will be x minus 1 all to the power of 1 over 2, as we said before. To integrate bracket with power, the rule is add 1 to the power, divide by the new power. But in case the bracket is multiplied by differentiation of what inside the bracket. Differentiation of what inside the bracket is 1. Here it's already multiplied by 1, so we can apply the rule, add 1 to the power, divide by the new power. It will be 2 over 3 x minus 1 all to the power 3 over 2. The second part, it's the same or similar. Bracket with power, we'll add or apply the rule. Add 1 to the power, divide by the new power in case the bracket is multiplied by the differentiation of what inside the bracket. Differentiation of what inside the bracket is 1, so already it's multiplied by 1. Apply the rule. So it will be 1 over 3 x minus 1 all to the power of 3. We'll substitute 1 time by 2 and 1 time by 1, then subtract to get the answer. And we have to write the substitution. 2 over 3 multiply 2 minus 1 power 3 over 2 minus 1 over 3 multiply 2 minus 1 power 3. It's 2 over 3. The second one, two over 3 multiply 1 minus 1 all to the power 3 over 2 minus 1 over 3 multiplied by 1 minus 1 power 3 equal 0. Here it's in this part it's 2 over 3 minus 1 over 3 equal 1 over 3. Here it's 0, so 1 over 3 minus 0 equal 1 over 3. Sorry, in this part, or the value of this expression, 2 over 3 minus 1 over 3. So the final answer will not be 2 over 3, it will be 1 over 3. So the value of the first substitution minus the value of the second substitution will get 1 over 3. 1 over 3 is the value of the area, units square. Question 24. When the area enclosed by y equal r, the x-axis, and x equal h is rotated through 360 degrees about the x-axis. A cylinder is formed with radius r and height h. Show that the volume of the cylinder is given by pi r power 2h. Here is talking about volume of revolution. We know that the rule of volume of revolution is integration from a to b pi y to the power of 2 dx. We have just to put values of a and b and the expression y in its place, or the function in its place, and integrate, substitute to find the value as we did in the definite integral. Here values of a and b. Here these are bounds of area, or bounds of integration. The area starts from this point to this point. This point we already know that it's 0, it's original point, and this point he said it's b, it's h, sorry. So this is a and this is b. So the value of a is 0 and the value of b is h. So we get the first information, which is 0 and h. Pi can be written inside the integration or outside, it's the same, no problem. What is the value of y? The value of y is already given. It's r, so it's r power 2 dx. Just integrate this expression and substitute by h and 0 to find the area. Here, if we want to integrate this expression, don't do this mistake. Don't say pi will be the same. Don't say integration of r power 2 is r power 3 over 3. It's wrong. Why we did this? Because here we apply the rule of differentiation or the rule of integration on the variable of the function. Here, what is the variable of the function? The variable here is x. So any expression or any part without x, without letter x, it's constant. Whatever it contains other letters or not. We said before, any term without the variable is constant. Its differentiation equals 0 and its integration just add the variable. So here the integration of pi r power 2 is pi r power 2 x from 0 to h. We'll substitute by h and substitute by 0, then subtract. So it will be pi r power 2 h, it will be pi r power 2 h. The other one, pi r power 2 multiply 0, it will be 0. If we subtract, it will be pi r power 2h, and it's the same expression. So here we have to pay attention. If we want to differentiate or integrate, we have to check this a variable or not in the expression. We said constant term means a term without the variable, not term without letter, because we can get a term with letters but it's constant. Constant term means its differentiation equals 0, its integration the same, just add the letter or just add the variable, as this question. Here r is not the variable, so we'll not apply the rule of integration, which is adding 1 to the power. Divide by the new power on letter r.